acquainted ourselves with this new symbolic language, the language of predicate logic or quantificational logic, we can now move on to get some experience symbolizing English sentences into this new symbolic language. We can do this by starting off with the questions in assignment 10. For assignment 10, the first page of the file is the question sheet, and then the later pages in that file are the solutions. We'll start off then in the top left-hand corner with part C. I'm going to be doing the questions that are starred with an asterisk and leave the rest of the questions for you. It turns out in symbolizing for quantificational logic, it's very difficult to come up with general or mechanical sorts of rules so that every time you see a particular kind of English phrasing, you can know that this calls for a particular kind of symbolism. Rather, you have to take every English sentence individually and you have to think, okay, what exactly is this English sentence committing me to about how the world is? Having done that, then you have to think, how in the symbolic system of quantificational logic can I symbolize what that English sentence is committing me to? And remember, there's always going to be two different ways of symbolizing it. One using an existential quantifier, one using a universal quantifier. So generally there's a decision to be made. Which of the two quantifiers am I going to go with, and what accompanying sentential characteristics are going to be required in order to exactly specify the same commitment about how the world is that's indicated by the English sentence. We can start off then with question 1 of exercise C. No Zoroastrians are Muslim. Here we have ZX, X is Zoroastrian, and MX, X is Muslim. If you think back to the Aristotelian square of opposition, this is an E-type sentence. No X's are Y's. So there's going to be two possibilities that are roughly equivalent in complexity. If we choose the universal, we're going to have all X are such that if X is Zoroastrian, then it's not the case that X is Muslim. If we go with the existential, it's going to be, it's not the case that there exists an X such that X is Zoroastrian and X is Muslim. Notice the universal is paired with the conditional, the existential paired with the conjunction, although there's always going to be any number of additional indications, in this case a tilde, to specify exactly what's indicated by the English sentence. Question 3. Not every marsupial is a kangaroo. It's not the case that all X are such that if X is a marsupial, then X is a kangaroo. This is an O-type sentence, and the way it's worded in English there, I would say, would suggest that version. An equivalent way of making this commitment about the world in English, though, instead of saying not every marsupial is a kangaroo, Someone might say there are some marsupials that are not kangaroos. In other words, there exists at least one X such that X is a marsupial, and it's not the case that X is a kangaroo. Either of these symbolizations is a correct one. If you want to, on the exam, provide both specifications, both symbolizations, keep in mind, if you get one right and one of them wrong, Wayne isn't going to give you full marks since you got at least one of them right. Rather, you're going to get marks off because you got one of them wrong. We can now move to question 7. Something is right. This is quite a simple one, and the existential, given that we see the word something, is the way to go. There's at least one X such that X is right. Of course, we can always symbolize this using a universal, but what would be required is it's not the case that all X are such that X is not right. Far simpler and more straightforward to say there's at least one X such that X is right. Now we can move to question 10. At least one mortal is human. There we have a nice, straightforward, I-type sentence. There's at least one X such that X is mortal and X is human. There's at least one mortal who is human. What if we wanted to, or had some use for symbolizing that using a universal? It's going to be a little more complicated than using the existential. At least one mortal is human. It's not the case that all X are such that if X is mortal, then it's not the case that X is human. So we can do it, but the existential is the way to go here, simpler and more straightforward. Then we move to question 16. Only blue things are sky blue. Here, we need to pause for a moment. What exactly is the English sentence indicating? So there were two predicates to consider. BX, X is blue, and SX, X is sky blue. The English sentence is telling us only blue things are sky blue. We might ask ourselves, is that sentence telling us that all X are such that if X is blue, then X must be sky blue? Or is it telling us all X are such that if X is sky blue, then X must be blue? Let's read the English sentence again. Only blue things are sky blue. It's telling us the second one. All X are such that if X is sky blue, which, if you think about it, is a type of blue, then X must be blue. It's not telling us all X are such that if X is blue, then X is sky blue. Here, you might keep in mind, with our symbolizations in sentential logic, if we had the word only connected with an if, what occurs immediately after the only, which in the English sentence 16 is blue things, that becomes the consequent of a conditional. Oh, we've skipped 13. We'll go back to it once we finish 16. So, all X are such that not if x is blue, then x is sky blue. Rather, if x is sky blue, then x is blue. If we insisted on an existential here, only blue things are sky blue, it's not the case that there exists an x such that x is sky blue and x isn't blue. Okay, back to 13. Some people are good and some people are not good. Here's our first example of a sentential logic structure that has two quantificational logic parts. Some people are good, which is just, there's at least one x such that x is a person and x is good. And, so in other words, this existentially quantified conjunction is one conjunct in a larger conjunction. Remember, the existential quantifier and the bound variable and the decorative brackets apply to this conjunction with brackets in the same way that a tilde would, so this is all one unit. No additional brackets are necessary. We can move on to the other conjunct. Some people are not good. There's at least one x such that x is a person, and it's not the case that x is good. Now we can move to 19. There exists an animal that has a soul. There's at least one animal, or at least one x, sorry, such that x is an animal and x has a soul. There's at least one x such that x is an animal and x has a soul. Being an I-type sentence, it calls for the existential. If we insist on doing the universal, there's at least one x such that x is an animal and x has a soul. It's not the case that all x are such that if x is an animal, then x doesn't have a soul. So a little more complicated. 22. All and only circles are perfect. So we've got Cx, x is a circle, Px, x is perfect. All and only. What we have here, you've probably guessed, is a conjunction of two A-type sentences. All x are such that if x is a circle, then x is perfect, and all x are such that if x is perfect, then x is a circle. And as you might have guessed, maybe I'll just put the alternative symbolization for 22 up here. That's going to be all x. Give myself a little more room. All x are such that x is a circle if and only if x is perfect. So this universally quantified biconditional is logically equivalent to this conjunction of two universally quantified mirror-imaged conditionals. We can end exercise C with question 25. Humans are featherless bipeds. Here we're adding one more level of complication. All x are such that if X is a human, then X is both featherless and X is a biped. I won't bother with the existential here. Notice then we've got a universal quantifier applied to a conditional, but instead of having simple sentences as the antecedent and the consequent, we've got a conjunction as the consequent of our conditional. So I hope, even by doing these few exercise questions, you're beginning to become familiar with how the terminology works and the kinds of symbolizations that will match commitments about the world indicated by English sentences. So you've got the majority of the questions in Part C to do on your own, and you've got the solutions. The best way to learn this stuff, really the only way to learn it, is just by doing a significant range of different questions so that you become familiar with the different symbolizations that are possible. Now we can move on to Part D. Question 1 says, a thing is a cat only if it is an animal. The first thing to say about this sentence is, I'm not the one who decided how the English language works. English is a natural language, and like any natural language, communities of speakers determine what various expressions or strings of words mean. On its surface, this, or the words in this English sentence, seem to appear that they're talking about a single thing. A thing is a cat. But in fact, what's being claimed here is that everything that is a cat has to be a mammal. A thing is a cat only if it is a mammal. This is one of the things that people who are learning second languages find notoriously difficult. Often, the better you know a particular language, the more easily, the more immediately you can be certain what the expressions in that language mean. A thing is a cat only if it's a mammal. So what's being claimed here is something about the types of things that are cats. A thing is a cat, it fits into that category only if it is a mammal. So what's being claimed here is that all X are such that if X is a cat, then X must be a mammal, rather than the false claim that all X are such that if X is a mammal, then X is a cat. I'll just stick to what strikes me as being the most plausible symbolization rather than giving both. Keep in mind though that in the solutions you'll be provided with both symbolizations. The second question with an asterisk, number 4, every logic student is wise. That's a straightforward A-type statement. All X are such that, just check the symbolization, if X is a logic student, then X is wise, so that's nice and straightforward. Question 7, everything is an illusion. Here, all X are such that X is an illusion. Instead of making a claim about the way that things having or lacking one property relate to things having or lacking another property. A claim is just made about everything possessing a single property. Number 10, nothing is right unless it is not wrong. This particular expression can be confusing simply because of the way it's worded. What's claimed here? Nothing is right unless it is not wrong. All X are such that X is not right, but then we have unless it is not wrong. Here we can follow what we learned about symbolizing conditionals in sentential logic. What comes immediately after the unless, we can put a tilde in front of it and make it the antecedent of a conditional. So this would give us all X are such that if it's not the case that X is not wrong, then X is not right. Of course, we're likely going to want to symbolize that in a simpler fashion. All X are such that if X is wrong, then it's not the case that X is right. Number 13. If everything is mental, then nothing is physical. Here we've got a conditional, the antecedent, everything is mental, the consequent, nothing is physical. The antecedent then is all X are such that X is mental. The consequent, nothing is physical. It's not the case that there exists an X such that X is physical. So notice each of the two parts is only referring to a single property or quality, namely being mental or being physical. So the conditional is as simple as that. When we move to number 16, we've got an interesting situation that we can contrast with question 19. So 16 says, if anyone is sad, then he or she is not happy. So we've got three different predicates, SX, X is sad, PX, X is a person, HX, X is happy. If anyone is sad, then he or she is not happy. How do we symbolize that? Well, since a claim is being made about the same subject in both the antecedent and the consequent, we'll want to symbolize it this way. All X are such that if X is a person and X is sad, then it's not the case that X is happy. So that the entire sentence is a universally quantified conditional. In contrast to 13 here, where the entire sentence is a conditional, with a universally quantified simple sentence as the antecedent, and the negation of an existentially quantified simple sentence as the consequent. Now let's consider question 19. If ghosts do not exist, then no houses are haunted. Here we've got three predicates. X is a ghost, X is a house, X is haunted. This sentence, like 13, is a conditional. And the reason we know it's a conditional is that the subject of the antecedent is different than the subject of the consequent, unlike question 16. So, if, and then we have the antecedent, ghosts do not exist. It's not the case that there exists an X such that X is a ghost. If that's so, and notice no additional brackets are necessary, then no houses are haunted. It's not the case that there exists an X such that here, since X is haunted and X is a house are both words that start with H, we can use HX to stand for X is a house, but when we come to X is haunted, we'll have to choose NX. So it's not the case that there exists an X such that X is a house and X is haunted. So that gives us a conditional with the negation of an existentially quantified simple sentence as the antecedent, the negation of an existentially quantified conjunction as the consequent. But they're focusing on different subjects, as is the case here. But in 16, since we've got the same subject, if anyone is sad, then he or she, the same entity, that's what makes 16 a universally quantified conditional rather than a conditional of two quantified parts. Question 22. Only large rodents are capybaras. So we've got X is large, X is a rodent, and X is a capybara. The thing to focus in on here, what comes after, immediately after the word only? Large rodents. So this is going to be all X are such that if X is a capybara, then X is large and X is a rodent because, as the English sentence says, only large rodents are capybaras. That doesn't necessarily mean that every large rodent there is a capybara. It just means that every capybara has to be a large rodent. So the class or group of capybaras is a subset of the large rodents, but not the other way around. Finally, none but surfers are cool. So, all X are such that if X is cool, then X must be a surfer, because the only people who are cool are surfers. None but surfers are cool. Notice that doesn't necessarily mean that if a particular person is a surfer, they're cool. The claim isn't that all surfers are cool. It's rather that surfers are the only people who are cool. So anyone who is cool must be a surfer, but the opposite conditional, all X are such that if X is a surfer, then X is cool, is not maintained by this English sentence. So that's part D. I'm going to skip over the short part E. That's a little test quiz you can take. And we'll move straight to part F. These are the challenging translations. Now we could consider the starred questions in part F in the bottom half of the right-hand side of the sheet there. The first one tells us in the English sentence, no rectangle is a square unless it is equilateral. So we've got X is a rectangle, X is a square, X is equilateral. All X are such that if X is not equilateral, then if X is a rectangle, then it's not the case that X is a square. Number 4, we've seen this one with the surfer question, none but surfers are cool. None but citizens can vote. So what does that English sentence commit us to? Commits us to a characterization of the world that can be symbolized as all X are such that if X can vote, then X must be a citizen, because only citizens can vote. There might also be citizens who are just too young to vote, so it doesn't tell us all X are such that if X is a citizen, then X can vote. It tells us that if X can vote, then X must be a citizen. Question 7. If all humans are mortal, but Socrates is not mortal, then Socrates is not human. This one is a conditional, and it's of an interesting variety because we finally got an example of a situation where the slot isn't filled with a bound X variable and an accompanying quantifier, but we've got a name as they include in the brackets HX, X is human, MX, X is mortal, and then lowercase s is going to stand for Socrates. If all humans are mortal, all X are such that if X is a human, then X is mortal. And the second part says Socrates is not mortal. It's not the case that Socrates is mortal. Then the conclusion, Socrates is not human. It's not the case that Socrates is human. So Socrates wouldn't be then the historical Socrates, who was both human and mortal. Would go like that. Okay, question 10. Fetuses lack a right to life if they are neither human nor moral agents. So we've got X is a fetus, Fx, X has a right to life, Rx, X is human, Hx, X is a moral agent, Mx. So the English sentence tells us fetuses lack a right to life if they are neither humans nor moral agents. What comes after the if clause is they are neither humans nor moral agents. So again, what is being spoken of here is all fetuses. So all X are such that, and coming immediately after the if X is neither human nor a moral agent, then if X is a fetus, then X lacks a right to life. This is one symbolization. You'll see in the solutions I've given a slightly different equivalent symbolization. As always, you don't have to worry that your symbolization is exactly the same as mine. In many cases, there's going to be a very limited range of entirely correct alternative symbolizations. As long as your symbolization exactly specifies the commitment about the world that's made by the English sentence, you're fine. It's my problem to figure out which of the various alternative versions will also be correct answers. All you have to think about is formulating the right symbolic sentence that exactly specifies the commitment about the world indicated by the English sentence you're symbolizing. We move on to 13. If Bob is a dog and all dogs are animals, then Bob is an animal. So, if Bob is a dog and all X are such that if X is a dog, then X is an animal. So, all of that together is the antecedent of a conditional, the consequent, then Bob is an animal. Finally, as far as the start exercises go, if anyone is both happy and sad, then he is confused. All X are such that if X is a person and X is happy and X is sad, so that's going to have to go together, but to keep the binary structure, we'll need to put two of the three conjuncts in the triple conjunction together. So we've got all X are such that if X is a person and X is happy and X is sad, then X is confused. There's a symbolization of question 13. So you've got the remainder of the questions in assignment 10 to do, and as I had said, it's not a situation I found where I can really give you a lot of general principles that will enable you to, whenever you see a particular grammatical construction or whenever you see key indicator words, that you can always reliably symbolize the underlying logical commitment about the way the world is in a certain way. Instead, you have to look at the English sentence, think about what it commits you to regarding how the world is, and then think about how to exactly match that commitment using the symbolic sentences. In the next video, I'm going to start things off by acquainting you with one final complication or one additional way in which the language of quantificational logic can be used to describe certain kinds of situations in the world. And after I've acquainted you with this additional aspect of the picture, so to speak, in quantificational logic, then I will go through in a similar fashion to what I've gone through in this video, a number of questions for assignment 12. This will leave us in the situation where you'll be able to do everything that's necessary to prepare for test 3.